All right, so architectures that you should know as an iOS developer in 2026. You may have heard some of these in the past, and you may have seen some examples, and you may have some assumptions about them that I'm going to hopefully break down and share with you a different perspective on each of these. And I'll show you a real world application that I'm building and putting on the App Store. So this is production tested. All of these, everything I'm about to show you is coming from a decade of experience working in iOS engineering, from small scale startups all the way to enterprise companies that are on the public market. And I think all of the knowledge that I've built over the years has been distilled into this video and how we should architect iOS apps. And I'm just going to jump right in. Okay, so the app in question is just a simple inventory app. My wife and I are using it to inventory our products after a recent apartment fire. There's like some smoke damage, and I just wanted to catalog off all the items that need to be replaced or cleaned. So it's like a really simple list view that we're going to be playing with today. There's the detail view where you can see within the item. There's also the add item workflow, and you can just add items, upload an image, whatever. And the idea here is that I'm going to show you how to orchestrate and build this in 3 different architectures that we're going to take a look at today. Model view model, the MVVM architecture, which is a UI architecture pattern that you'll see most common with SwiftUI views and SwiftUI projects. In my experience, it doesn't matter. The UI layer is separate from presentation logic and business logic, and we'll take a deep dive into all of that today. Model view controller, there's a lot of assumptions around this one. I'm saying like, hey, model view controller doesn't work. It leads to massive view controller. It's not testable. And I'm going to just give you a quick preview and kind of share with you where we're heading in this video. That is not true. Like I can seamlessly build my SwiftUI application with MVC, and I can also have it fully tested with a controller that has all the business logic and contains any services within that. And I can have like a test suite set up for that controller. So as you can see, I have my controller test here. Yeah, it's fully tested. So I'm here to break down all these assumptions today, and we're going to show you, big picture, what's going on. I'm also going to go deep dive into different patterns and understand like where are some limitations, are there any at all, and how does this look on our real world application. So by the end of this video, I hope to have given you like a new perspective on client architecture and giving you like, some more exposure to different patterns that align with, best practices, clean code, clean architecture, all that. And we also take a look at model view presenter in the same way that we have looked at MVVM and MVC. The key message that I want to share to you all is that there is more than one way to do something really well. And it's all a matter of like, collaborating between you, your stakeholders, your fellow developers on your team. And if it's just you, just go with what feels right. For the majority of this project, I've been using MVVM. But I want to show you that all of them are possible, and you can do them all in a way that is scalable, maintainable, and testable. All right, so let's take a look at MVVM. Enough of me yapping. All right, so from previous videos, the core principle is that like, hey, you can build an app that has core functionality that is able to be modular and placed in multiple app targets. And the only thing that is relevant to that app target, and what I mean by app target is like basically the app platform. So we have iOS, which contains your iPhone, your iPad. There's Mac OS, or your MacBook. Your TV OS, so that's like the Apple TV. There's so many. There's Vision OS. I feel like I'm missing one. Watch OS, there it is. And the only thing that changes there is your UI, and your UI is conforming to the patterns that, or the protocols that the core module uses. So essentially it's like your UI depends on the core and not the other way around. And we want to keep that distinction clear and in mind when we're building out our UI architecture. So when you hear about, model view, view model, or model view controller, or model view presenter, these are all like UI architecture, right? Because we're only orchestrating how actions are taken throughout the app and how our system handles those actions and responds in state, so the UI can change its view based on that state that the system is asking the UI to change. So these are more commonly known as UI architecture patterns rather than just architecture. I hope that makes sense. If not, just ask me some questions or reach out to me. All right, so high level, let's look at MVVM. You have your view model that sits in the middle. I've kept this color coding where blue is meant to represent the core of our app, of our system. This has like the business logic, any logic that the presentation should listen to or ask the system to make changes on, that will sit in the core layer. So it is UI independent, or UI agnostic, as you might hear, whereas the UI is depending on this core system to understand, hey, if the user takes an action, how should I send that to the system? And if the system responds or updates the state in any way, what should I listen to in order to change the view state for the user? All right, so our view model will handle any actions that is coming from the view, and it'll make any changes to the model. The model will update, and the view model will recognize that update, and it'll essentially push that update to the view for the view to update its state. So now looking at that deeper, we're going to look at a specific view called the item list view. And that was the inventory view that we just took a look at. Just a quick reminder, this is the item list view. And essentially, we're going to be dispatching user intent, or essentially user actions from the item list view. So when a user taps the cell, it's basically saying, hey, I want to take this action to navigate. Or if a user taps add, it's essentially like saying, hey, I want to add a new item. That is intent that we're going to be sending off to the view model. The view model will be doing something, whether that's fetching items, taking some action, and it may or may not, make a network call to a service to fetch some results. So a good example of this is like, hey, I just landed on this app. The item list view would say, hey, get me some items to show on the screen. So like when you open the app for the first time, it's going to dispatch that, hey, user's ready to fetch some items. The item list view will fetch the items. It'll make a call to the service if it's not already cached. It'll return some result, and the item list view will listen to the state of the view state that sits in the view model. So basically it's like a read-only situation where we want to make sure we maintain like a unidirectional flow. So you'll hear that in more senior environments where they're saying, hey, you don't want the view to dictate the state of the app. You essentially want it to listen rather than make any updates to keep it clean and clear. So let's take a look at this in code. So here are my tests. We want to go to our source, and I keep everything in that core package. Look at previous videos if you have any questions on that, or just reach out to me. But essentially, the item list view model, it has the networking dependency, which is the service that fetches the items. It exposes items and certain view state to be listened to by views, but it doesn't publicize the mutation of these state properties. It all stays internal. So essentially, any views that are listening to this view model will only be doing reads, or will be listening rather than dictating. And it goes for any properties on the view that needs to be updated. They're not going to be making the updates explicitly, but through these intent patterns of in the form of functions like, hey, update this text. These are like the actions that we're dispatching to the view model from a view. So as you can see, this is all here and not in the view. So we don't want the view to be in charge of state properties. We want the view to dispatch actions to the view model, and the view model will update these state properties, and the view will bind to the read-only portion of these state properties. So it maintains that unidirectional flow, and that's like best practices, so you don't run into messiness with dependencies, and yeah, it's just a lot cleaner. So as you can tell by now, I'm very rigorous on my testing, so I'm going to go ahead and show you what it looks like. So here's my view models test. It's pretty extensive. Has fetching, success states, error states. When there's no items, it also handles the search cases, and we're also handling these intent dispatches. So update search text, update categories. These are all actions that a user is taking. So let's say I want to look up mattress. It's looking up mattress. All of that is being handled on the view model, and the view is just listening to state changes rather than updating the state. So if we go back to our architecture diagram, itemless view is, asking the view model to make updates. So it's saying, hey, I took this action. The view model says, okay, like user took this action. What should I do? Are there any network requests that needs to be made before I make any state changes? If not, make the state change, and the itemless view will listen to the state properties on the view model. Okay, so that is MVVM at a high level, and you got to see some code, you got to see some tests. So now let's see how the view models are used with the views. So let's go to our iOS app. So as you remember, this is all modular, so my views are not contained within my core package. And the core package has all the business logic, presentation logic even, but the UI itself sits in that respective app platform target. So I'm looking at the iOS app target. So here you are, I have my view model being passed into this view, and for properties that my view is listening to on the view model, as you can see, I have like these very clear mechanisms of binding data to my view. In order to get any data from the view model, I get the explicit public property on that view model. So if we look at new photo data, I'm looking at, so yeah, I did it for another item detail screen. So we'll look at this first and then go to the item list view. So it's basically saying like, hey, whenever there's new item photo data, I want to get that from the view model. So the view model is holding that reference to the data, and the view will be getting it from there. And when the view is setting new data, it is calling an explicit update function that will change the state property internally of the view model. So the view doesn't have explicit control of the state. It essentially makes a function call to the view model so that all of that logic is handled within the view model and never in the view. There's never a case where state is being updated in the view. So now that we were looking at the item detail view, let's go back to our item list view and see this. So when I'm typing in search text, I'm getting that search text from the view model, and when I'm updating the search text in terms of like setting it to be sent to some service or the view model, it's an explicit function that runs through the view model and never the search text being set by the view. Okay, so if I make any selections, same thing. All of my logic is being handled in the view model, and it's done through like an explicit way of binding. So as you can see, I'm getting list items from the view model, and yeah, it's it's fully tested. We know that our view models have tests, our services have tests, and we have a router for navigation. I can take a look at routers in a different video, but yeah, that essentially handles the navigation. That also has tests. So all of this is set up for long-term scalability, maintainability, and it's fully tested. So yeah, that's MVVM. It's pretty straightforward. It's not a lot of lines of code, like only less than 200. If I want to look at the view again, the view isn't that long. There's a lot of previews here, or some previews under 200. I could, break this down into different subviews, into different folders, but that's just creating, unnecessary mess. And yeah, it's pretty straightforward. So that's MVVM. And now let's take a look at our next UI pattern. All right, so this is the MVC. So with this one, you may think like, wow, why would anyone ever consider MVC with SwiftUI? That makes no sense, Apple's kind of told us like, hey, use MVVM when you're building SwiftUI apps. I think MVVM is more than enough. It's adequate. And I just wanted to explore this pattern to kind of to test the validity with that, with folks saying like, hey, can't use MVC. It's not clean. It leads to too many dependencies. It's going to lead to like a large controller. And I just wanted to challenge that and explore it. So can we maintain clean architecture with MVC? Let's find out. All right. So in the historical context of MVC, it's typically having a controller as like a mediator. That just means that it's the one orchestrating events back and forth between the view and the model. Controller has reference to the model. Model makes any updates. Controller updates the view, and that's typically the way it's been. With SwiftUI, you could still maintain that same paradigm where the item list view is dispatching some user intent and some user action. The item list controller recognizes this and it does some logic. It has the business logic there, whether that means it needs to make a service call to fetch items or it just needs to update text somewhere. It still has this publicized but private for setting, private for mutation property that a view can listen to. So we're going to look at that, and it's pretty similar to the MVVM setup. I'm going to switch over to that right now. So let's look at our item list view for MVC. Okay. So we're using a controller, the item list controller. Let's take a look at that first. This is basically holding our dependencies, our network dependencies if we need to make any networking calls. It's also holding state to handle any view state changes that the views will be listening to. Search and filtering state essentially is also published on this controller, but is private for mutation. So you see this private set essentially that says you can only make changes internally in this class, but it is public for listening and being binded to. So all of the business logic on filtering is here, fetching, making any networking calls. So our service is still fully tested. So this is our networking service that is calling our item service. So we have the test here. I can run those tests pretty quickly, and because it's modular, everything's really fast to build, fast to compile. That took seconds, and it's running. Let it run. So these are running all of my tests related to the inventory feature, and it passed. Okay, so now we're going to go up a level and let's look at our controller test. So one key thing that people shared is that controllers are hard to test, and I tested that theory and it turned out to not be true. So I have fully tested the item list controller. So that holds all the business logic of our item list using the MVC pattern. And as you can see, everything here is testable. So I'm just gonna run that again. Passing. Okay. So let's move to our views. Give me 1 second here. Okay, so here we go. Let's look at our item list view, MVC. Okay, so as you can see, same setup as the MVVM. All we're doing here is that instead of the view model, we have replaced it with a controller. We have the explicit bindings to make sure it's unidirectional, so that we're only reading state updates from the controller and never explicitly setting the state updates from the view. So all of that, any user actions are being sent to the controller, and the controller is then in charge of making any service request or updating the state. So all of that state management is handled within the controller and never within the view. The view is essentially stateless. Okay. And as you can see, here are our subviews. This is listening to state. And yeah, less than 200 lines of code. So very similar to MVVM. Could break this down further, but be unnecessary. And let's actually see this in code too. So let's see this in the app actually with MVC. So we have this here, and I'm just gonna update the title to make sure that we're using so you can see the MVC screen is being used. Otherwise it's really hard to tell the distinction. So let's go here, and let's go to our tab, make sure we're using MVC. All right, let's run the app. Okay, this should be relatively quick. Because it's all modular, any build times are pretty fast because we only changed certain parts of our project. All right, so it's building. Here we go. Loading well, MVC. Okay, and as you saw, it's fully tested. Services are tested. The controller is tested. I could add snapshots later, but given that it's just like a small project, I think maybe if it expanded long term, I'll add some snapshots, but for now it's fine. Just prototyping here. And yeah, everything works using MVC. Okay, so that's MVC. If you have any questions, just follow up in a comment. I hope you guys are enjoying this so far. I'm fairly new to sharing all of my knowledge online, so happy for feedback. And if you wanted to get more information, just reach out. Okay, let's look at model view presenter. So this one is a little different in that the intent is more explicit. Let's take a look at that in code really quickly. It's very similar to the previous patterns that we took a look at. And let's go here, inventory, presenters, item list presenter. All right, cool. So the main difference with the presenter pattern, the MVP, is that the view state is typically extracted out into a struct or a class. It's just more explicit. And I think, in my opinion, it's a little cleaner to have the view state as its own struct. That way it's more explicit to the reader, the developer that's reading the code later in the future, of like, okay, like this property is part of the view state as opposed to something else. So I really like having the view state as a struct, is what I found. And I could have easily done this with my MVVM and my MVC setup as well. But for the purposes of MVP, I'm just gonna keep this view state pattern in MVP. Okay, so let's look at the presenter file. As you can see, there's an explicit struct state here. I could have put this in its own file to clean things up, but I just put this at the top for now. As opposed to, listing out all of the different properties here, it now has an explicit state property in the presenter that has all of these properties. And same dependencies, same setup for initialization. The initialization of the state could also be passed in, but for now we're just going to start with like a brand new state. So as you can see, we're still calling our fetch calls. All of that logic is handled in the presenter. And yeah, all of the updates from the view is being handled in the presenter and not explicitly in the view. Okay, so let's look at our test for this. So I like to use TDD and write my test before my code, and that's why I have like a pretty extensive test suite. You don't need to do this, but in my decade of experience, it's much better to have tests than to not have them and wondering why things aren't breaking or why things are breaking. Okay, so as you can see here, tests are easy to write. Let me make sure I'm in the right scheme. I think I was in the wrong scheme. Okay. And because the core package is written with a UI agnostic approach, I can run my test in the Mac simulator, and that just makes it faster. So it doesn't need to spin up the simulator to make the test run, and they pass. So as you can see, you can run that again fairly quickly, and they're passing. Awesome. Okay, so let's take a look at the presenter and use. So let's go to our app target. Let's look at the views. MVP. Okay, so we pass in the presenter, and same binding principle of only getting the state from the presenter, and the presenter has like the public properties for reading, but never for setting. So it's essentially like a read-only view state. So the views can listen to the state changes on the property, but never set them explicitly. They have to go through these public methods. Okay, so going back to the view, very similar setup to the MVC and MVVM pattern. Yeah, it's pretty clean. Let's see, under 200 lines. Yeah, almost the exact same lines of code for all three. Previews are pretty simple with my mock setup. If I wanted to take a quick look at this, let's move over to our iOS scheme. Let me get out of the way here. Okay. Because everything is mocked up and using dependency injection, I can at runtime put in like a mock instance of anything. This is just basically saying that it built successfully. If I want to look at different views, like the add item with MVP, same situation. It's quickly rendered. If I want to look at item detail, MVP. And all of this would have been really difficult had I not done clean separation and using everything in like a monolith in one repo or one app target. Like having this core modular function makes it 10 times easier to build and 10 times easier to test. Yeah, it's really simple and straightforward. Okay, so I'm gonna run the app with the MVP architecture. Let me just make sure that it shows that it's MVP. So update this title to MVP. See the preview's updated immediately, and I'm going to use the MVP pattern. Okay, so let's run this. So yeah, I just wanted to show you all what was possible and how quickly I can spin this up in different architectures without much issue, and everything's fully tested. Just waiting for the app to build here. And it's all streamlined through the intentional architectural patterns that I chose. Yeah, look at this. Worked like a charm. and let's take a look. Yep, everything's there. Awesome. Okay, so big picture, what does all of this mean? Why are we doing all this? Is it even necessary? I think it's okay and perfectly fine to just stick with MVVM. But I do think that like if you're finding yourself going down these rabbit holes of like, oh, this architecture is better than the other, and that typically happens in like large teams and large companies, I would just challenge you to take a step back and really test that assumption, because you might be surprised and each of them might be perfect for a specific use case and will be adequate to get you to where you want to be. So I hope this was useful. This is the architectural diagrams for each. I'm going to share all of this in the description. I hope you found this useful. Let me know in the comments if you have any questions or reach out. I think I'm going to be starting a community soon where you can join and get more info behind some of these architectures and learn more about how I build apps. Thank you for watching. Have a good one.